Yeah, Assalamu alaikum.
Walaikum salam, sir.
Today we have to start the measure of location. In this section, we will discuss median, mode, quartile, decile, and percentile. So, let me try to understand these things. First of all, to measure median, mode, quartile, decile, and percentile, we must arrange our data in ascending order. Now let we have our data on this line. So first of all, what is the median? Median actually a point which divides the data into two halves. So this one is the median. This one is median. Okay, let's say the median. Okay, if we need to divide our data into 4 equal parts, the purpose for doing this is only when data is with larger range. We have collected data for months and years. So that's why this is necessary to study them, to analyze this type of data in sections, in the, different time intervals. So this is the reason to calculate these measures. Okay, when we need to cut our data into 4 equal parts, for this purpose, we have to cut it at 3 places, quartiles. This one is Q1, in the center Q2, and this one Q3. Each section contains 25% of the data. Okay. Now, if we need to cut our data in 10 equal parts, so for this purpose, we will cut it at 9 places. At 9 places. So these 9 cuts. These 9 cuts are called quartiles, deciles. Each one is a decipart, 1/10th part of our data. And we denote it by D2, D3, Here we have D5. This one, let's say D7, and last one D9. So remember, quartiles are 3 in number, deciles are 9 in number. So when we need to cut our data into 100 equal parts, so we will cut it at 99 places. 99 places. Each one is each one is a 100th part. Like this. So these 99 cuts are called percentiles, and we denote them by P1, P2, P3, P4, up to P99. P1, this will be D1 will be 10, and this Q1 will be 25, and this Q2 will be P50, D7, P70. Here we have P60, and last one 99. So remember one thing, by definition, the meaning of quartile, decile, or percentile now from here. By definition, note that what is the definition of median? Median is a point. Remember this note. Median is a point that cumulates, add up or sum up, cumulates of the data below this point, because our data is in ascending form. If it is in descending form, descending order, then median will be a point that will accumulate 50% of the data above this point. So no need to discuss both the things at the same time. Just remember one. Other one is obvious. Okay, then what about Q1? Q1 is a point that accumulates of the data below this point. Similarly, let's say Q3. Q3 is a point which accumulates 75% of the data below this point. D7 is a point that accumulates 70% of the data below this point. Similarly, let's say P45 is a point which accumulates percent of the data below this point. So we must remember the amount of the data which is collected in this section. That is quarter part, that is n by 4 in this case. This is the ratio, and this ratio is 25%. In this case, for Q3, this ratio will be 3n by 4. In this case, this ratio will be 7n by 10. N by 10 is a 10th part, and 7 times 10th part means 70% of the data. In this case, n by 100 is 100th part of the data, and 45 means 45 n by 100 means 45th percentile. Now discuss this example. Let's say we have a data of 20 values, find different quartile, decile or percentile. So first of all, we must arrange our data. The first mistake in these problems usually students do. They don't arrange the data. So how could be the other measures correct? How can you get a correct answer if you don't arrange the data? Okay, first of all, arrange the data. Let's say for third quartile, first of all, we must know the ratio 3n by 4. What is that? N is 20. So the value of Q3 is 15. Mention here whether this ratio is integer or non-integer. If it is integer, then take the average of 15th and 16th, next one, 16th item in the data. This will be your required measure. This will be Q3. What is Q3? The average of 15th and 16th values or items in the data. Trace out those values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16, these two. So find their average. These values are 96 and 97 divided by 2. The answer is 96.5. Actually, we are tracing out a cut which represents Q3. So 96.5 here in between these 2 points. This cut will be Q3. Okay, for D7, first of all find the ratio, whether it is integer or non-integer. Again we have integer, so D7 is the average of 14th and what is D7 by 10? Yes, 14. So average of 14th and 15th values in the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. In between 95 and 96. So for D7, the average of 95 and 96 that is 95.5 is the required seventh decile. Similarly, P17, we have 14, so P70 is the average of 14th and 15th value in the data. As we know, most of the values are overlapping. That's why D7 and P70 are the same. What about the median? Median is either the middle value or the average of two middle values in the data. So in this case, which is average of 89 and 93 in this example. The average of 89 and 93. This will be the answer. '89 plus 93 divided by 2. 91. 91 is the answer. Okay, we have discussed only one side of the situation when the ratio is integer. Okay, let we have this type of data. When we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 values in our data. Then Q3, what about Q3? That is 3n by 4. Again, we find the ratio first of all, and we will check whether this ratio is integer or non-integer. In this case, this ratio is now non-integer. So apply bracket function to this non-integer value plus 1. This will be the position for Q3. We get the position at 12. So 12th item, not the value 12. Q3 is not equal to 12. This is just indicating the position of the value. So 12th item in the data is our third quartile. What is the role of this bracket function? This bracket function note that bracket function provides, let's say, when applied to a value x, It provides an integral value which is equal to x, or an integral value just below x. Means the bracket function of 3 is 3, bracket function of 7 is 7, bracket function of 37 is 37, and now the other case. When it is integer and we apply bracket function to an integral value, it gives the same integer. This is the role of bracket function. But if it is not integer, let's say 3.1, it will provide an integral value just below this point. Even for 3.9, as 3.9 is non-integer, and we apply bracket function to this value, this will give us an integral value just below this point, just below 3.9, which is again 3. Even if we have a situation that we are applying a bracket function to a non-integral value 3.9999, even then it is non-integer. Therefore, bracket function will provide us an integral value just below this point. So remember, this note. Okay, this was the situation when we have an ungrouped data. We arrange this data and then find median, quartile, decile, and percentile. But what will happen if we have our group data? We are given a group data. Let's say consider any frequency distribution that we have discussed in previous examples. Let's consider group data of frequency distribution. 10 to 19, 6, 7, 8. Okay. One, two, three, four, five, 6, 7, 8, 9. So we have certain classes and a frequency. 10 to 19 to 20 to 29, 30 to 39, 40 to 49, 50 to 59 to 69, 70 to 79, and 80 to 89. We have this situation. Okay, the frequencies. 6, 7, 8, 7, 8, 10, 9, 7, 4. So for this situation, let's say we need to calculate median, first quartile, 7th decile, and 45th percentile. Also calculate mode. In previous case, when we have ungrouped data, mode is the most frequent value. That will be the mode. Maybe there is no mode, but if some value having comparatively more repetitions, that will be the mode. Okay, in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 classes. So 3, 4, 5, 6, 7, 8. Classes and frequency. 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, 60 to 69, 70 to 79, and 82 and 89. The frequencies are 6, 7, 8, 6, 7, 8, 6, 7, 8, 10, 12, 9, 7, 4. So remember, for this case, we must have class boundaries. So first of all, we need class boundaries. Convert these classes to class boundaries. How can we do this? Class boundaries. There is a difference of 1 between two consecutive classes. So subtract half of the difference from all lower class limits. We get 9.5, 19.5, 29.5, 39.5, 49.5, 59.5, 69.5, 79.5, and add half of the difference to all upper class limits. We get 19.5, 29.5, 39.5, 49.5, 49.5, and here we have 59.5, 69.5, 79.5, and also calculate cumulative frequency. First, as it is, add 7. We have 13, 13 plus 8, 13 plus 8, 21, 21 plus 10, 31, 31.12. 43. 43 plus 9, 52. 52 plus 7, 59. 59 plus 4. And total frequency is also 63. Okay, what about the formulas? Formula for median. Median is L1 plus H over F. H over F. H over F backslash F. H over F and H over F L1 H over F. No, I forgot. Let me check this formula. Median formula for group data. Okay, I'm sorry. N by 2, here we have N by 2 n by 2 minus c. This will be the formula for median. And also we need a Q1. So formula for Q1 is almost the same. We will have n by 4 here. Rest of the formula is the same. Okay. Uh, just for the understanding, let's say we need the calculation of Q3. So this will be the formula. Here we have the ratio 3n by 4. In all calculations, only this ratio will be changed. Okay, next we need D7. For D7, change this ratio. This ratio for D7 is 7n by 10. Rest of the formula is the same. And finally, we need P45. Again, change the ratio. This ratio will be for P45, 45n by 100. Now, first of all, understand these notations L1, H over F, C. All right. Let me try median. Median. First of all, find this ratio n by 2. What is n by 2? 31.5. 31.5. Is it? So look at this value in cumulative frequency. If we round off this figure, because we need n by 2 values where they are cumulated. We are finding a point which cumulates n by 2 values of the data below this point. N by 2 data means 50% of the data below the median. So n by 2 is, by rounding off, we have 32. So look at this column of cumulative frequency where 32 values are cumulated. Here 32 values are cumulated. So this is our expected class in which median can fall. This is our, here in this interval, our median can fall. So also we have highlighted this class interval, but from class boundary. L1 is this class boundary, lower limit of this class, 41.5, 49.5, value of L1 plus age. What is age? Age is overall class width. In all these cases, the class width is 10 and it is uniform 10. And what is the value of f? F, the frequency of this highlighted class, which is 12. Okay. And value of n by 2 is 31.5 minus C, value of C. Value of C. The value of cumulative frequency above this class. Above this class. Okay. The value of C is 31. And simplify, this will be the answer of the median. Now for this purpose, first of all, find this ratio, n by 4, 63, 63 by 4, 63 by 4, 63 divided by 4. We have 15.75. 15.75. Now again look at this cumulative frequency column. Where 15.75 values are cumulated. 15.75 values means 16 values. 16 values. So this is the class. This is the class for first quartile. Now easily now we can trace out the other values. 29.5, the value of L1. What is the value of H and F in this case? The value of H remains same because all the class intervals are the same. But the value of F, the frequency of this highlighted class interval, which is 8. Value of n by 4 is 15.75 minus C. What is C in this case? C in this case is 13. 13. So simplify and get the answer of Q1. Similarly, try all other measures. For all these measures, first of all, you have to calculate these ratios, then highlight the corresponding class interval and find the other values, L1 and the frequency, and also the value of C. Now, if we trace out an ogive for this distribution by considering midpoints along x-axis and cumulative frequency along y-axis, this will be the ogive. For median, let's say, for median, find out here the value n by 2. Again, we need to calculate all the ratios, corresponding ratios. For median, we need n by 2. So find here n by 2. If n by 2 is here, draw a line parallel to x-axis as it is touching the curve, drop a perpendicular on the x-axis. This value on the x-axis will be the median. For Q1, calculate n by 4. Let's say here we have n by 4. N by 4, draw a parallel line to x-axis as it touches the curve, drop a perpendicular on the x-axis. This value on the x-axis will be Q1. Let's see Q3. For Q3, we need the ratio 3n by 4. Let's say here we have 3n by 4. Draw a parallel line to x-axis, touching the curve, drop a perpendicular on the x-axis. This will be the value of Q3. Let's say we need to calculate D7. For D7, the ratio is 7n by 10. Trace out 7n by 10. 7n by 10. If it is here, draw a parallel line, touching the curve, drop a perpendicular on the x-axis. Here we will have the value of D7. Similarly, any decile, any quartile or percentile we can calculate using ogive. So this is the best use of the ogive. Now, what about the mode? N1 plus FM minus F1. In the denominator, we have Fm minus F1 plus Fm minus F2. Multiply by H. So this will be the formula for mode. So what happens in this case? First of all, find the value of Fm. Fm means highest frequency. So look at this column of frequency. Here we have the highest frequency of 12. This is the value of Fm. This is the value of Fm. Remember this one. Above this Fm, we have F1, and below this we have F2. This one is this one Fm, and this one F2. L1, what is L1? L1 is the lower class limit of the interval corresponding to Fm against highest frequency. Trace out this class interval. Its lower limit is the value of L1. What is H overall class width? So we have almost all the values. Value of L1 is, in this case, 49.5. 49.5. What is the value of H? 10. And other Fm. Fm is 12. F1 is 10. And value of F2 is 9. Simplify all this. You will get the value of the mode. What happens in case of ungrouped data? Just find out the value with highest frequency. Find out the value with the most repetition. But in this case, we will find these measures with the help of certain formula. Okay, for practice, try these questions from book 1. Now just take a break of 10 minutes. Then we will discuss rest of the things. We will be here after break. Measures of dispersion. From here. Just 10 minutes. Discuss dispersion measures. Dispersion means spread, scatteredness. So how the data is scattered? We can measure this with these formulas. One is the range. Range tells us about the dispersion of the data. Maximum minus minimum value. The most simple dispersion measure. Coefficient of dispersion, xn minus x naught divided by xn plus x naught. We use coefficient measures for the purpose of comparison. So that we could avoid different units of the variable. Interquartile range Q3 minus Q1 when we need to discuss middle 50 values of the data. Again, we have a coefficient of quartile. Before this coefficient, we have quartile deviation. Q3 minus Q1 divided by 2. Quartile deviation. And also the quartile deviation, that is again for the comparison of the two sets of data or more than two sets of data. Mean deviation. Mean deviation here we have used a modulus here. That's why this is called absolute measure. We use this when our data contains both positive and negative values. Xi minus x bar means just the distance from a value from the mean value. A distance from of a value from the mean value. So, but if a mean is negative and x is negative, we have a different situation. So in this way, we have too much violation, too much as spread than the actual one. So to avoid this difficulty, we just take the absolute value because we need the distance. How much the values are deviating from the mean value. That is the only purpose. So find all the distances, sum up and dividing by 2. So this will give us an average distance of the values from the mean value. But remember, don't try to sum up the difference xi minus x bar. There must be an absolute sign here. Otherwise, this sum will be equal to 0. Due to this property, xi minus x bar is just the deviation from mean value, and the sum of the deviations from mean value is always 0. But in mean deviation, we must put a modulus sign here for the calculation. Next one is the variance. Variance is the mean of the square deviation from mean value. This is the definition of the variance. Variance is the mean of the squared deviations from mean value. Look at this formula. What we have within the brackets, we have xi minus mu. That is just the deviation from mean value. Deviation from mean value. And take their squares. So we have squared deviations from mean value. Find their average, sum up all square deviations from mean value and dividing by their number. This is called the variance. Also, we have some alternative formula. You can also try them. Standard deviation. Next is the standard deviation. Standard deviation is just the positive square root of the variance. Like this. Positive square root of the variance. Again, this shows the deviations, how the values are falling apart from the mean value. For example, in construction, in manufacturing, let's say we set a criteria. We need a uniformity of in our construction or in our manufacturing process. So, but when the things are prepared, when the things are manufactured or constructed, we don't have that criteria. All the things are not necessarily same. There may be a little difference, a minor difference. This is called the variation. Sometimes the value is less than the criteria, and sometimes it is more than the criteria. So this is actually the deviation from the mean value. Mean value is our criteria, but the things don't exist in an ideal way. There always we have a variation, and this exists in the nature. So that's why first we calculate this variation and then decide and set a precision level to accept the situation or to reject. Next is the coefficient of variation. Coefficient of standard deviation, just the variation with respect to the mean value. Standard deviation divided by mean. The standard deviation, the spread with respect to the mean value. And coefficient of variation, if we multiply this ratio by 100. This answer will be in percentage and this answer will be in ratio. For the calculation of all these measures, we just have to construct a table. For example, we are given these blue highlighted 20 values in our data. Sum up and divide by their number, we get the mean value. Okay. Now for the standard deviation, if we use the alternative formula, first find their squares. The squares of all the values and sum up, dividing by 20. And here, sigma x over n. Sigma x is the sum of first column, this and this, 1800, 03, 1803, divided by n, and then taking its whole square. Remember this situation. Remember these sums. Student, don't construct this second column. They just square the sum of sigma x. But sigma x whole square is not equal to sigma x square. Remember this situation. You have to construct a column of x square separately. For the mean deviation, we have calculated mean. So first find x minus x bar with positive sign because we are taking the modulus. Sum up all these modulus values and using in this formula. In the numerator, the sum of all the modulus values divided by n. Again, remember, mean deviation is never equal to this formula. Is not calculated with this formula. We have to use modulus. Otherwise, we will get the answer 0. Coefficient of variation, again, very simple, sigma by x bar multiplied by 100, and we express it in percentage. We use this measure for the comparison. We have two sets of data, we have two information, and calculated there coefficient of variation. One is 5.7 and another is 14.8. So we can compare both the variations. As the value of coefficient of variation is larger, this means this variable having more variation than this one. Next time we will discuss, inshallah, empirical rule and Chebyshev theorem and skewness and kurtosis. I have uploaded this book, the first one, in the group. This one. This book I have uploaded. And also I will send these class lecture notes on the group, inshallah. Up to page 14. Today, inshallah. Any question? You must ask the questions wherever you feel some problem during the lecture even. We will proceed with the mutual discussion. एक और याद रख लें, ये खुतबा नहीं है कि भी मैंने खुतबा दे दिया और आपने सुन लिया, अब इस पे अमल करना अब आपका काम है. नहीं, ये नहीं है, ये you have to discuss. Today 40 participants are there. I am taking their attendance. Even if you find some problem, some query, please send me a message on WhatsApp group. And also you can individually ask me through WhatsApp message. I will reply inshallah. Okay ji, Allah Hafiz.